Hello, everyone, and welcome to the Evil-Driven Battle. This is an unusual hackathon because this is an actual battle between the two different toolkits that we are providing. And we're happy to talk about the technologies, about the tools that you may use during the hackathon. So I will shortly explain you the schedule and the technology, and then I will pass my mic to Anupam. He's the one of the partners from Truera. He will tell you more about the event itself. So let's go. I'm Katya. I'm going to be your MC today. And yeah, just please remember, if you have any questions, like you can also ask them during the Discord. I will tell you more about questions part in the platform walkthrough. Then moving on to the event schedule. So we're kicking off today. We will have 3 workshop sessions prepared by Truera, by Llama-Index, and by MongoDB. Then we'll also have a general Q&A. Then we'll also have general Q&A within the next week on Monday and as well on Tuesday. And as of next Friday, the hackathon will be finished and you guys will have to submit all of your projects by the deadline. So I'm pretty sure that all of you are familiar with LabLab platform, but for those who are new here to the platform, LabLab AI is actually like a system, platform where you can build, you can create your products, your startup ideas. You can basically like here is the playground of your creation. You're submitting projects. Your projects are being evaluated by the valuable partners, by the valuable judges. And then you just see how your project is going to be growing later on, right? After you submit a hackathon. So of course, like winning and stuff is very important, but what's most important is just to create and to build with new technologies that we are gladly providing for our participants. So this hackathon is sponsored by our valuable friend, partner, Truera. And their TrueLens technology is all-in-one toolkit, which enables you to evaluate LLM-based apps. And for those who didn't use Truera yet, then please check out tutorials and tags. We have a lot of tutorials devoted for TrueLens. And yeah, like you will find there a lot of useful information how to embed this technology into your app. Also, as I mentioned before, moving on, we are partnering with MongoDB and Llama-Index, and this is one of the, let's say, like toolkit that you can use for this hackathon. And please go ahead, like if for those who don't know the technology, like we have tag pages for MongoDB, Llama-Index. We have also useful information. So please go ahead and just get acknowledge how you can mix these technologies into implementing your app. With that being said, I want to also kindly remind you that it's really important that you have your Truera account. So please, all the participants that registered on our platform, don't forget to create Truera account so you will be able to also participate in this hackathon. And now I want to pass mic to Anupam. Anupam just will tell you a few kind of opening words from Truera side. And after that, we will
Quel est le
move on
Wi-Fi, s'il vous
to
plaît?
platform.
Je suis dans Astoria 24, pas de majuscule? OK. OK, merci beaucoup. Astoria 24, merci, au revoir.
So thank you, Katya, and welcome everyone. It's a pleasure to welcome everyone to this hackathon that we are kicking off today. We have done a few now with LabLab AI and various partners, and it's been wonderful to see how much gets built in just a span of a week. And we're looking forward to seeing the exciting applications that you build and evaluate with TrueLens. over the next week or so. So just to remind folks, this is the tool face-off between OpenAI Assistance API and our partners, Llama-Index and MongoDB. It's also partly sponsored by Intel. And it's going to be really cool to see how the two sets of tools measure up against each other using TrueLens as the building block to do evaluation and iteration to improve your applications. There are quite a few resources and workshops that are coming up today that I'd like to highlight. There are resources about TrueLens right on the Hackathon webpage here that you can see on getting started, as well as for OpenAI Assistance API. There's a bunch of different models you can play with. And then if you, as I scroll down to the schedule today, very soon we will kick off with a workshop on advanced evaluation methods with TrueLens that I'll lead with Daniel Huang, who's a machine learning engineer at Truera. Next up after that is how to build advanced RAGs with agentic strategies with Llama-Index by our friend and partner, Laurie Voss, who's the VP of Developer Relations at Llama-Index. And shortly after that, we'll have a session from MongoDB on retrieval augmented generation with MongoDB. That'll be led by Prakul Agarwal, who's a machine learning product manager at MongoDB. I've personally had the pleasure to work closely with Laurie and Prakul on a number of previous sessions as well. And I highly recommend that we all join those sessions. Those would be excellent tutorials for you to get started with these toolkits. With that, let me wrap up here. We are here to build and have fun and learn through that process. Without further ado, welcome again, everyone. And we look forward to seeing you at these workshop sessions pretty soon and supporting you as you build some really cool applications over the course of the next week and engage in this head-to-head tool face-off with us. Thank you.
Thank you, Anupam. So I'm continuing my presentation on the platform walkthrough before we move on to workshops that Anupam mentioned about. So as Anupam already told you about the challenge, there are going to be different tool sets, the OpenAI Assistance API and Llama-Index MongoDB and GPT-4, and all of them shall be mixed with TrueLens technology. So please use one of each. Yeah, you have a choice, and it's up to you. When it comes to success criteria, honestly, like nothing is new here. Basically, four super important points is application of technology, presentation, business value, originality. And if you manage to reach success in all of them, well, that's just brilliant. But if you, as I like, think that application is more important than being original, it's also okay, because in the end of the day, it's just really important to address the actual problem, to solve it, and to show how technology has been useful to solve that. So as for hackathon prices, that's pretty cool, actually. There is a main track and there are special prizes. Main track is pure cash. Sounds sweet. And you can also win special prize. So important note here that I need to explain is that you can win like one prize of the main track, and you can still be nominated for a special prize. So it's not like, like these prizes, they are not competitive, like there are different, let's say, like ranges, and still like try to be the first in the main track, and why not get in the special prize for the best use of toolset 1 or toolset 2, depends on which one you're going to choose for creating your app. moving on, mentor leads, as usual, you will have access to Discord channel where you will talk to mentor leads. They're super helpful advice, and they're going to help you to build your apps. So now a very quick platform walkthrough. I know that there are a lot of repetitive participants, right? But we still need to onboard those who are new. So here's the guide on the platform itself. Please make sure that you have your team on LabLab AI. It's either you're creating one or you're joining one. Then you also have to meet your team on Discord. Everything has to be in Discord, like all communication. You're basically like deciding the concept, or you already had one, but you have to, well, basically like have your chat, have your group, and you will be also assigned with the mentor who will guide you through the process. Then, well, obviously you're building your prototype, you're building your demo, you're doing presentation, you're submitting your project, and that shall be done in a week from now by 18 p.m. set time. So regarding your profile, LabLab is also pretty cool for networking, I would say. So just please try to insert as much info as you want, as you think is relevant for your profile. It will help you to connect and to be, I don't know, like chosen for a team if you look for one, or, you know, just genuinely like tell about yourself. Creating team, I already told you about that. This is just a screenshot where you will see the list of teams, yeah, where you can join or just to create one. So moving on to the next slides. Yep, this is about the Discord. Like, yeah, just please make sure that your Discord is connected also in LabLab. And there you should also create your own team, as I mentioned before. Moving on, communication with mentors. Tag in mentor on Discord. You will find in the LabLab AI channel on Discord, you will find the hashtag, the name of the hackathon, where you can talk to mentors and just ask for help. And there is also a channel called specifically for help with the hashtag I need help. And there you will just, you know, like ask your questions around. And just quickly wrapping up with everything, your presentation is actually key to your success, because this is a very short 5 minutes of your, let's say, like shine time, right? And you need to catch attention by your presentation. So don't make it dull, make it like actually, you know, standing out. There's so many projects, there's such a tough competition. Make sure that your product demo is working. Make sure that your presentation is short and sweet and to the point. Your demo, GitHub, all the links are working. Project description is also pretty clear, explanatory, and well, appropriate. Yeah. And of course, as usually, like you cannot present longer than 5 minutes. Please follow this deadline. Just submit your video, yeah, and it should be good enough. I want to pass mic to the first workshop by basically concluding that, again, if you need any additional help, please Discord, and there you will find the necessary channel. There you also have I need help channel, and there you can also tag your mentor. So with that being said, I am finishing the platform walkthrough, and I am passing mic again to Anupam, yeah, with the workshop. How are we doing with the workshop? Are we ready yet, or not?
I think we are scheduled to start at 9:30 out here, and
Yeah,
we
that's
need
true.
so yeah. There's also Danielle Huang who will join us. I think he has a note out to you, Katya, to let him into the Discord setup. So Maybe we
Yep.
break for a few
So,
minutes and reconvene at 9:30. Is that okay?
mm, I don't see any problem, frankly. I think we can actually, we can actually do the break. Let's see maybe if we have any questions on the channel in the meantime. Yeah, guys, please just shoot your questions on the Twitch, and we will just answer them in the chat. So let's make a break and meet up at 9:30 again.
Welcome back, everyone. We are kicking off this workshop to introduce TrueLens and how to use TrueLens to evaluate the Assistance API and Llama-Index plus MongoDB Atlas as you start this tool face-off hackathon. In this presentation, our focus and emphasis will be more on TrueLens, and in the next two workshops, we will go deeper into Llama-Index and MongoDB. Joining me today is Daniel Huang, who's a senior software engineer at Truera and has done a lot of work in this area. This at this GitHub page that you can play with. So here's the quick outline. We will begin with an intro to building and evaluating RAG apps, very quick intro to what are some of the challenges with hallucinations and more, what makes evaluating RAGs hard. Then we'll go into an introduction to TrueLens in particular, showing you hands-on how to experiment and evaluate RAG systems as you build with the Assistance API and you build with Llama-Index plus MongoDB plus GPT-4. The next two workshops will go deeper into Llama-Index and the MongoDB Atlas capabilities. So to begin with, I wanted to show you this very quick example. We asked Claude 2, who are the founders of Truera, and this is what it came back with. And it's very emblematic of how large language models work in that it got a number of the general trends right. There are three co-founders, the area in which Truera works is accurate. However, a lot of the specific facts are incorrect. It got my name right and my background right, but the two other co-founders are real people. Somesh is a good friend of mine, but they're not the co-founders of Truera. We were founded in 2019, not 2014, and we were definitely not acquired by SAS. When we went from Claude 2 to Claude 3, things improved a little bit. Now Shayaxen is included. He is indeed a co-founder and CTO at Truera, but a third co-founder is still incorrect. And this brings up this challenge that when you
All right, so we are off.
Thank you. Apologies. There was a internet glitch and I lost the connection for a couple of minutes while I was speaking eloquently about the problems with LLMs and how RAGs address them. So let me redo that section. I was mentioning that if you just use LLMs directly for question answering, hallucinations is a huge problem. And in order to address that problem, retrieval augmented generation was introduced and has become really popular in building production grade applications. Now, if you think about how retrieval augmented generation works, it takes that insight which I just shared, which is LLMs are good at general tasks, but are not good at memorization. And it shifts the memorization tasks to a vector database, which stores the knowledge base. So whatever data you have, your knowledge base, which in an enterprise could be internal data, or proprietary data, that data is taken, it's chunked up into smaller pieces, converted into embeddings, and stored in the vector database. Now, when the user comes in and asks a question, that query then gets converted into query embeddings by an LLM. And then there is a similarity search between this query embedding and the previously stored chunk embeddings in the vector database, and that produces results of the top k most similar chunks in the database, which then get shared with the LLM to complete and generate the final response. Now, this addresses the problem of hallucination to some extent, but it does not completely solve that problem. And there are still a number of different ways in which RAGs can break. There's a lot of different choices for chunking strategies, and depending on which strategy you pick, you will get very different results in terms of the quality of your application. And with TrueLens, what you'll be able to do in this hackathon is to evaluate your RAG applications, whether you're building with the Assistance API or with Llama-Index plus MongoDB plus GPT-4, to discover these failure modes and get guidance on how to improve the application to make it better and to measure that improvement through metrics. So chunking strategies is one way which will have an impact on the quality of your application. The data quality matters a lot. The embedding quality matters. The retrieval results quality or search quality matters a lot. Query analysis, context can overflow. And finally, through an interaction of a number of these factors, you might get very significant problems with hallucinations. So given this set of problems, what I want to dive into next is a quick introduction to TrueLens that will help you evaluate RAGs along for these kinds of failure modes, troubleshoot and improve your applications as you're building them out in this hackathon. And then we'll show you a notebook and a hands-on flow with a couple of examples. So in recognizing that last year, a lot of the emphasis was on experimentation, on prototyping of applications, we introduced TrueLens. With that purpose in mind, for developers, it's an open source, anyone can use it. It's an MIT license, so you can use it commercially as well. In 2024, we also launched a product that connects nicely with TrueLens and scales up to production workloads and monitoring. And so if that's of interest to you, you can check that out as well. Our focus in the hackathon will be with TrueLens, the open source library. So how do you evaluate RAGs for hallucinations? We introduced last year the concept of the RAG triad, which has now gotten very widely adopted across lots of different projects. The RAG triad very much follows the structure of the RAG, where the user comes in with a query, there's a set of retrieved pieces of context from the vector database, and then finally, there's a summarized response by the LLM. And on each edge, there's an evaluation. Context relevance checks, is the retrieved context relevant to the query? Groundedness checks, is the final response supported by these retrieved pieces of context, these authoritative documents, chunks that we trust? And then answer relevance checks, is the final answer relevant to the query? So for each of these, There are implementations in TrueLens for these evaluations using what we call feedback functions. And shortly, Daniel will walk you through the notebook to show you in code what's involved. The main thing I want to highlight is that as you are evaluating or doing comparative evaluations between apps built with the Assistant API or with Llama-Index and MongoDB, these are the kinds of evaluations that you'll want to do as a starting point to guard against hallucinations. In addition to the RAG triad, which is a useful starting point, there's a number of other evaluations that are available out of the box in TrueLens that you can use depending on the type of application that you're building. And in particular, TrueLens has this abstraction of a feedback function, of what we call a feedback function, that provides a score after reviewing an LLM app's inputs, outputs, intermediate results, and metadata. And it's useful to ensure that apps are honest and harmless and helpful. The RAG triad is in this honest bucket, but we also have evaluations to guard against harm, such as toxicity, bias or stereotyping, jailbreaks and adversarial attacks, as well as elements of language-based evaluations for conciseness, coherence, and so on. Another kind of nice capability is this capability to add custom evaluations, so you're not limited to the 20 or 30 evaluations that are available right now out of the box in TrueLens. You can also add your own, which better matches the needs of your application. One other element that we want to share is what's under the hood. How do we think about the space of evaluations and the trade-offs between them? Often when developers are building applications and they're thinking about evaluating their quality, they start with ground truth evals. By that, what I mean is evaluations are done using a curated data set for which the right answers are known. And then when you get results out of your RAG or other LLM-based application, you can compare the responses from the LLM to the ground truth evals and assess how well it's doing. This is a useful place to start, but it tends to not scale very well because creating these curated ground truth data sets requires a lot of domain expertise and a lot of work. Next up is human evals. So once you have built your application, the developer himself or herself can look at the results, eyeball the results, and form a point of view on how on point are the results, responses coming out of the application. In many cases, the applications are deployed for use by a certain set of users, and the users themselves can provide feedback on the quality of the responses. And these human evals scale a little better because the set of users of the product of the application might be larger than just the true experts who are curating these ground truth data sets. On the other hand, they're still expensive to collect and can have quite a bit of variance. So on the x-axis, on how meaningful are these evaluations, we have moved left a little bit relative to ground truth evals. On scale, it's a little bit better. So on the y-axis, we have moved up. A lot of the interesting action in the space of evaluations, though, is with programmatic or automatic evaluations, which are these bullet points above the x-axis. One useful place to start is traditional NLP evals like blue scores and rouge scores, which many of you I'm sure are familiar with. So if you think of a summarization use case, you have the original document and then you have a summary of it. And these kinds of scores can help you assess how much of a match there is between the summary and the original document. However, they do tend to be quite syntactic. So in a summarization use case, it'll look for overlap in words or sequences of words or tokens between the summary and the original document, and that can cause false positives and false negatives. A lot of the new action and new insights on evaluations is with LLM evals and with these medium-sized language model or MLM evals. With LLM evals, and you will see a lot of them in TrueLens already available out of the box, and you can play with them and tweak them. LLM evals tend to have quite strong agreement with human evals. However, they tend to be expensive. So there are some interesting research results. For example, a paper that came out of Berkeley last year, which talks about judging LLM as a judge. And it shows that human-human agreement is about 80 to 90% on their benchmarking data sets. And LLM eval agreement with human evals is also in the same range of 80 to 90%, which is why on the x-axis, I have placed it along around the same point. At the same time, they can be quite expensive, so they're absolutely fine for use in this hackathon and during development and experimentation. But in production, if the workloads, if the data volumes go up quite a bit, then the LLM eval-based monitoring can get quite expensive. So it's also useful to have work with these smaller, medium-sized language models, like BERT style of models, although that requires more fine-tuning, more work to provide the right feedback. So as you look at the space of evaluations in TrueLens, you will find elements of these. The RAG triad implementation is with large language model-based evals. On the other hand, things like language mismatch are being evaluated with these medium-sized language models. So with that background, now I'm going to hand it over to Danielle to give you a hands-on walkthrough with a notebook of how to experiment and evaluate the RAG systems with TrueLens, with specific focus on the assistance API and building with Llama-Index and MongoDB and GPT-4. I also want to encourage you to join the next two workshops led by Llama-Index and MongoDB team that'll go deeper around related examples and notebooks. And with that, let me stop sharing and hand it over to you, Daniel.
Thank you, Anupam. Yeah, so hopefully my audio and videos are good. Welcome, guys. Excited for the hackathon. So here, as Anupam mentioned, in my sessions, I will try to, since it's a live stream, so it's a little hard for interaction or like back and forth conversations. But I will try to make sure I leave ample of the resources, the link, example notebooks, and some of the sort of like pointers for some of the I guess like documentations I have found like in previous 2 years like be very helpful and to you guys so that you guys can reach out to me during the next week several days and like see dive deeper and very exciting to see what you guys will be building. Yeah, so with that I would say like today's session is mainly about evaluating RAG systems. Why evaluating is hard or evaluation is hard. And then sometimes it's really like all you need to have a RAG systems like working end to end. It's like imagine having a RAG system like for the past years, everyone is trying to dump into their custom data, building even like agentic applications, right? Single agents, even like multiple agents, trying to cooperate. All in all, like with this like seemingly unlimited capability, it also comes with it pretty much just magnifying the undeterministic nature of a lot of like LLM-based applications, or at least if your applications has some sort of reasoning being powered by LLM. So here, the first example, we'll be talking about, I guess, well, here I'm just gonna flash this QR code real quick. I'll talk to, nice folks from Llama AI so that we will have more link coming. This specific URLs, I believe, directly link to a collab notebook containing examples about like how do you iterating your RAG-based application using MongoDB, and then see if you can kind of like identify the failure modes using different type of RAG architectures. The orchestration here is built with Llama-Index, which we will show will be shown the code very soon. And the vector database or the vector search index is building use MongoDB's Atlas cluster, their SaaS offering. And then finally, we'll see how you can actually address those failure modes and then correct them in the next round of iterations and re-evaluate with TrueLens to actually observe some sort of a qualitative and quantifiable improvement. So yeah, so with that, the first example will actually be, so yeah, let me go back to the overview slides. So the structure will be, we'll start out with a quick notebook using Assistance API from OpenAI. And the second one will be a combination of several tools. Like I mentioned, the orchestration is going to be Llama-Index. The vector databases or the vector search will be powered by MongoDB. And then finally, for the LLM itself, we'll be using GPT-4. More specifically, this is the GPT-4 Turbo. Latest training data, I believe, is from December 2023. So about like 4 months old. And then this will also include some sort of vision capability. So it is a multimodal model. So feel free to try it out in your own hackathon projects. Cool. So let's start off with Assistant APIs. Assistant API is relatively new. This is released by OpenAI about, I would say, 7 months ago, last fall, if I remember correctly. Currently, there are 2 versions of Assistant API, but in my view, at least this, by the way, this source, the source of this slide is from OpenAI. The Assistant API is for you to build. It's an all-in-one place for you to build any type of sort of like AI assistance. So it's not just limited to RAG. In fact, when Assistance API started, like I said, 8 months ago, hopefully I didn't get the date wrong. It wasn't like actually specifically tailored toward RAG, but in the past, the quarter or so, they added a lot of RAG like capabilities, like vector search, and then they started out with like great like support for tool usage. So the first tool they support is Code Interpreter. For the folks who remember ChatGPT, the Pro plan from last year, they had this like as a plugins for some time being, but then now it's all integrated as like just say a tool that your LLM could pick from and then execute it against. So Assistant API not only is limited to like OpenAI tools, it can also perform function calling on any tools you build. By tool here, I really mean like they are just function, right? So they can very well be like a web search function, an API that you host yourself, or it can be any other publicly facing API that you found online, or it can even be like a self-contained algorithm that you wrote yourself. So you can really do a lot of things, but the main constructs in Assistance APIs are just a top level assistant. So this is sort of like a instance of your system. In our cases, it will be a RAG system. Now, the thread is sort of like a conversation interaction section or history between the agent or the assistant and the users. Okay, so this being divided into user message, assistant messages. So for the folks who have worked in Llama-Index or LangChain, this construct might seem very familiar. Indeed, this is like pretty much just like a chat message template, right? So yeah, in the run itself, it is the actual instantiation of execution of the interaction between your assistant and your the user itself. So yeah, so a couple of things before I dive into the code. Currently, the latest Assistant API is actually undergoing a lot of changes this month. So April of 2024, Assistant API is formally migrated to V2. That's what OpenAI called it. Now, there is a caveat that I found during this, like diving into this hackathon actually. So Assistant API, previously there is a very well received function or feature. Basically, when you are doing retrieval, right, against your own documents, it is able to find the file citation. For example, if you have several files uploaded, and then you, oops, did I get disconnected? Oh, okay, cool. So if you have several files uploaded, the Assistant API is able to grab the file citation when it's trying to answer your question. And then in there, the most important feature is that it's actually able to quote the source of the references or sort of like source materials in the original uploaded document when answering your question. However, this functionality, due to some instability issue that is actually reported from OpenAI staff, this functionality is currently removed in V2. So when you are building in the next week of hackathon, just make sure you are aware of this difference between the V1 and V2. On the bottom of this, well, at the end of this hackathon the presentation, I will also link you to the migration guide. You can easily find it on OpenAI's platform page or their documentation page as well. So be aware in V2, even though arguably probably the quality is improved because you can upload almost like infinite number of files. It's like 10K files as of this month. You can upload it and then it will handle all the chunking, embedding, keyword search and vector search all in one place, one stop automatically for you. Now, the limitation or the drawback on the other hand is that currently you don't have any configurability there. You cannot configure your own parsing. You cannot configure your own, like embedding model you want to use. You cannot configure your chunking strategies like Anupam mentioned, which is actually very instrumental or very crucial in a lot of rack systems. So all these things are the current limitations that folks please be aware of on the current assistance API. That being said, despite being like a sort of like a black box lacking some configurability, it is a very powerful tool. So that's why we are like pitting this directly against Llama-Index and MongoDB, and we are very, very excited and I can't wait to see how you guys build with that and see the quality that you can evaluate with TrueLens. Cool. So I'm going to switch it off a little bit to the actual code. So this is the example notebook that we'll be sharing. I'm going to go a little bit faster. So the first part is just to install the dependency. Noted here, I have the pinned version, OpenAI version. This is a version about a month old. The reason I'm not using the latest one is exactly because of the limitation I mentioned. Folks, you can go to this community forum. You can find the official answer from OpenAI staff mentioning why they removed the feature. And then we will very soon see why this quote feature is very important in terms of evaluation. Cool. So like standard setup, you will need to have your OpenAI key since we'll be using GPT-4 as a backbone LLM also for this assistance API. And the documents, this is just an example. So we are grabbing this very well known program essay here, which is a fairly short essay, a couple of thousand tokens. And then to instrument your app with TrueLens, this actually all it takes is several lines of code right here. Probably the maximum of 10 lines. So here you will instantiate TrueLens locally. You can locally will automatically create SQLite file for you, but you are free to connect to any database instances remotely. That if you have any DB connection string, we have documentation supporting like how you can connect to them. But for local development for Hackathon, I would just highly suggest just use your local, and I will show you the UI very soon. Now to create a thread, this is V1, like very important. This is the V1 assistance. So very, very minor difference in the syntax here compared to the latest one. There, again, OpenAI's documentations has all the details. Here, you will pretty much just have your file's ID here, and then you wrap around your file. This is the file we uploaded. This is the program essay. So here, all you like this line pretty much instantiate the assistant for you in your OpenAI account. Now, this decorator is a magic of TrueLens. The single line of decorator here, if you instrumented that, you will be able to have all sorts of insights directly derived from this application. And I will soon show you like how that actually gets done. But the rest of it, like just ignoring the decorator, the rest of it is just creating a thread. Like I mentioned, thread is the interaction between user and assistants in OpenAI. And then these are all very standard syntax from assistants API. And then finally, you will have a response. And another one is the quote. So this is a difference. In V2 Assistant API, at least the last time I tried, which is yesterday, you wouldn't be able to get this quote, even though this is being supported seemingly on their documentation, but the feature is actually removed. Okay, so why would we need a quote, right? Because remember in our RAG triad, in terms of hallucination, when we are talking about how you can make your app less hallucinatory, you can, a lot of times, you can have some sort of probable answers, right? Folks here probably already experienced that quite a bit. Probable answer has high answer relevance, meaning the answer is actually relevant to a query, and then maybe half of it or even like the entirety of it is correct. However, if you are using a RAG system, you will actually want your application, not just an LLM, right? You want your application to be able to retrieve the correct source or the correct context from your own databases, from your own vector database, from your own documents, however you want to call it, from your own custom data sets. You will actually want to have the right retrieved context in order for your response to be well-grounded. To be well-grounded, it means the responses, every sentence, every claim in your response is actually supported by some sort of source piece or context, right? So without a quote, you cannot really do that. You cannot really know if your responses is just a result from your pre-training, from your pre-training data set of the LLM, right? The LLM is the best at trying to, sorry, let me mute my. Sorry about the back voice. Yeah. So going back to the quote, right? So this is why we would need this quote to be extracted, hopefully by Assistance API. Now, creating feedback function is the crux of TrueLens. Here we have 3 feedback functions. The first one is groundedness, like the one we mentioned in the RAG triad. The second one is answer relevance. The third one is context relevance. So all 3 things evaluate different pillars of this RAG triad. Now, for context relevance, you will see this selection, sort of like this structure. This might seem a little convoluted at the first glance, but in reality, this is actually very, very powerful. The reason we need to have this is because all LLM applications, whether it be agentic, being a RAG-based application, being like a simple summarization app, they all comes in different form factors. They have different shape, they have different internal or intermediate components. So it is very important for an evaluator, a powerful evaluation library like TrueLens, to be able to adapt to them with great flexibility and adaptability. So here you can see the name of the function. The record is just the top level, sort of like a construct in TrueLens, but the retrieve and generate is the function name you define above. So if you are looking at, sorry about that. Is it better now? No problem. Yeah. So in order to evaluate the context, right, we want to make sure if the retrieved context pieces are actually relevant to your question, right? So we want to take a look at the quote. So here, the reds, this is a return, like a collection of your return value. So the second element of it is the quote. So this is what I meant by, even though all these kind of app, you can have all different sort of like a list of arguments, all different type of return return objects, or any type of really return a construct in Python, you could instrument that with TrueLens easily. So and then here the provider, they are being backed by GPT-4. So if you're using OpenAI, you can easily swap out different model like GPT-4, Turbo, etc., using different variants of the OpenAI models. Finally, this is just a thin wrapper around the Assistant API app, which we formerly named in RAG, and then you will get a leaderboard. Now, this doesn't really mean much, but until we head toward the actual TrueLens dashboard. So I'm going to show real quick what that dashboard looks like. Okay, so this is the actual TrueLens dashboard that I'm running locally. There are 2 applications here. You wouldn't see the Assistant API one because this was a dry run, but we will dive deep into every record here in the next 5 minutes. Sorry, I had to speed that a little bit, but this is TrueLens application, and then you will be able to zoom in to see all the elements like I mentioned, with your instrumentations and however you defined it. Again, we will have all kinds of documentation ready. Now, going to the second part, this is still TrueLens, but now we are evaluating using different tools, right? We are evaluating using MongoDB plus Llama-Index plus GPT-4 as a backbone API. And now we will actually go into the TrueLens UI to see how you can improve the quality of that. So a little bit different from the Assistant API, which I mentioned is like an all-in-one, one-stop API or construct that you could just build your RAG upon. Now you have more fine-grained control, arguably, with all these different components, MongoDB, Llama-Index, and different LLM apps or different LLM models that you can switch between. So let's first quickly start with MongoDB. We will have a follow-up workshop on how you can create an index here. But what we are doing here is that we go into the Alice UI, we create a search index, or actually, step correction, vector search index, name vector index here. Then we make sure we have the correct embedding dimension that match our embedding model. Then we will try to evaluate. So going back to the code here, again, the starting point of here, now we have a collect link as well. So we can view it in Colab. You can easily download it here using the, not download it, you can easily access it here using the QR code that we had in the slides. But the first step is the same. You import TrueLens. The only difference from the previous one is that now we are no longer using Assistance API, but using Mongo plus Llama-Index plus GPT-4. So the only API keys you will be using still is the same OpenAI ones that you might already have. The second one is in Mongo connection string, which again will be covered by nice folks from Mongo in the next hour. But like I mentioned, here we are using, now we have fine-grained control, right? Granular control. We can swap out different embedding model for your use cases. Maybe you are building apps in different languages. Maybe you're building apps in healthcare. Maybe you are building apps in different like financial services. So you might want to use different embedding model. But here I'm just using OpenAI embedding, and the embedding dimension is 1536. That's the reason or the significance of this particular, sorry for jumping around, particular piece of your embedding dimension. So we want to make sure this embedding dimension actually match whatever embedding model you are using that can be easily specified by Llama-Index. The setting here is a global setting. It's a global variable provided by Llama-Index. And then now, as opposed to Assistance API, you could, at the moment, easily select different chunk size and chunk overlap for your RAG systems. Now, the simple data we use, just because we have granular control, is way more, sort of like way more engaged here. It's like there are 3 different long documents. The first one is a LS best practices PDF file, about 20 pages. The second is a very, very long book called DB Essentials. It has 112 pages. So for folks who are interested in building application in Hackathon with long documents, this is where you want to look at. The third one is a presentation provided by Databricks. Now we have 3 documents. Why is that, right? The reason for that is, well, building a single document or like a single agent is fairly easy, right? It's fairly straightforward. However, a lot of time you have different documents. They are all maybe related, but they have their own, obviously their own content. And then you want your retrieval, you want your even like a tool execution to be precise. You want your agent or your application as a whole to be intelligent enough to pick the right document to retrieve the most relevant context. Then folks can imagine this will have huge impact on your token usage, so affecting your cost. And then it will also have even bigger impact on the overall latency, right? Imagine if you cannot, like your LM app, your systems cannot deterministically or reliably pick the right documents, then your system might be going around circles, going around cycles actually, trying to figure out which document to use, especially prominent in agentic use case, in agent use case. So Llama-Index here provides a very, very nice framework here for you to be able to pick different documents using not vector search, not semantic search, but actually using something way more reliable. You could just use something like a metadata of your documents, like the name of your file, right? To select which document that is most relevant to your query. So here I have a ls vector search being created, and remember the index name we're using just called vector index. Then the rest of it is Llama-Index, very nice syntax sugar for you to be able to wrap around and then have your vector store specified here. And then we specified it, and then we add the feedback function. Again, TrueLens play with all kinds of like major players in the orchestration framework. So you can use LangChain here as well, but here obviously we're using Llama-Index. So for that, again, Very similarly, we are creating 3 main feedback functions. Obviously, you're not limited to 3. You are free to create many more. But here you can see they're slightly different here as opposed to the one we had with OpenAI assistants, right? Now we are directly instrumenting, or like we are sort of like zooming in and then looking at different part of applications. It's just looking at the input and output for your answer relevance, and it's looking at your input and a single piece of context to evaluate your context relevance. And then finally, it's looking at all of your context and then find the output to evaluate your groundedness. Now, this is all relevant to this particular triangle here we're talking about, right? So if you want to evaluate groundedness, you want all your context pit against or compare against responses to make sure every sentence in your response is actually supported by the context. I have 3 minutes left, so speeding through. Again, you can run feedback function individually. Feedback function, it will output a score, but even better, for selected number of feedback functions, it will provide all the reasoning, saying like why it is evaluating your app on context relevance of 0.2. The feedback score currently is normalized to 0 to 1, between 0 to 1. And the test cases here are just the user queries I'm going to ask. So, and then that's good. Good testing. Right. So I have 2 versions of application here. The first one is basic RAG. The second one is the one, like I mentioned, I actually use the metadata as a filter to figure out which file I'll be using. So this corresponds to the multi-document Llama-Index agent. So the Llama-Index agent will be able to figure out using the file name, like which file to be routing to. And with that, with all the example code that check the overall results, you will see the first version that is not using the metadata field for filtering actually has way lower groundedness score than the one with the router, the query router plus metadata filtering, right? So the groundedness score actually almost double. Why is it like such a huge improvement? In my final minutes, I am going to share the actual usage of that. So a question I picked, sorry about that, here. Okay, so here's just a nice UI, right? Remember base RAG that we built. The second iteration of the app we built is called filter speed2, grounded score 0.47 all the way up to 0.86. And why is that? Let's pick the first version of the app. The question I want to pick here is the one with 0 grounded score. The question I ask is, what is fast? FAISS is a Facebook AI semantic search. So this is a terminology for folks who worked in vector search or a retrieval space will be very familiar with. The response is fast stands for Facebook AI semantic search. This is the correct answer, so that's the reason it gets a perfect score on answer relevance. However, it gets 0 both on context relevance and groundedness. The reason for that is if you drill deep down into the different components here, you will actually see, let's click groundedness here, you will actually see here, this is the final statement, this is the answer, and this is the source. And this is a nonsensical mathematical formulas that is probably retrieved from a long document that we call like a DB essential. It has over 100 PDF pages. But either way, it doesn't contain anything relevant to FAISS, right? So this is completely not supported by the evidence. Supporting evidence, nothing found. That's the reason the feedback function is giving it a score of 0. Okay. Now going back to the second iteration of the app, clicking to the same question, go to groundedness, we see it is actually retrieving computing Euclidean distance between and then this sentence here is actually from the correct documents. This document, data provided by Databricks. This is the PDF file I downloaded at the beginning of my notebook. So if I search for FAISS, here, compute Euclidean distance, this particular slide with the Voronoi cells, all the stuff here is the exact supporting evidence I want. And then now you can also see like the answer here is a slightly more, like a slightly more detailed and then more concrete, right? No longer it just give you the full name. It actually tells you it's a search library, right? It's not, just something like it telling you the acronym. So yeah, so that's the end of my presentations. I'm running a little bit over. Apology for that, but feel free to reach out to us. Yep. Getting a time check here. Yes. Feel free to reach out to us. And here it's like one quick example that you can just iterate and improve drastically the quality of your application as a whole. We can do better, right? There's an example on TrueLens. We have a Colab notebook that you can use vector search plus hybrid search with Llama-Index. So we will make sure we share this after the stream. Thank you. That's all of my presentation.
Thank you, everyone. We appreciate you, and check out the notebooks. And thanks, Danielle. And we'll hand it back to you, Katya.
Are we ready with Laurie? Shall be ready with Laurie. Laurie, here.
Hi. Yeah.
Hey. Okay, so let's introduce. Laurie is a DevRel from Llama-Index, and he's going to give a workshop today. This is going to be for, well, we're a little bit late on timing, yeah, so, but please take as much time as you need. And the workshop that Laurie is going to provide is about the advanced RAG with genetic strategies with Llama-Index. So I'm passing mic to you, Laurie.
Thank you. Let me share my screen. Are you seeing my slides? I can't hear you, but I can't hear any complaints, so I'm going to assume
Yes,
that's
we
going
can.
okay. Great. So, hi, everybody. Like Katya said, my name is Laurie. I'm VP of Developer Relations at Llama-Index. I've been a developer for 27 years now. Before that, I co-founded a couple of companies, including NPM Inc. But these days, instead of talking about JavaScript, I'm talking about AI. Today, we're going to be talking about retrieval augmented generation and using agentic strategies to build agents that can do it for us. First, we're going to recap what retrieval augmented generation is very briefly. What is it? Why do we do it? What do we get out of doing it? And how do we do it? Then we're going to dive into Llama-Index and talk about how we do it specifically using Llama-Index and how Llama-Index helps you get retrieval augmented generation done. We're then going to level up with 7 advanced techniques that can do more advanced and subtle RAG applications. And then I'll switch to talking about how to get your app into production once you're ready to do that. If I've got time, and we'll see how we do, I'm also going to dive into a couple of notebooks that'll show you step-by-step how to build agents in Llama-Index. So let's start with retrieval augmented generation, or RAG. Fundamentally, RAG is a response to a limitation of LLMs. They are trained on mountains of data, but they are not trained on your data. So if you want to run queries on your data, you have to give them that data. But you can't give them all of your data at once at the moment, simply because they can't handle it. The largest context window that exists at the moment is on Gemini Pro, and it's 1 million tokens. But even that's not enough. You probably have tens or hundreds of millions of tokens of data to play with. So you have to be selective about what data you give an LLM. And even if you had an infinite context window, you wouldn't want to give an LLM all of your data every single time to answer every single question. You need to be selective for reasons of speed and cost. So you get a bunch of things out of doing RAG other than just surmounting this limitation. You get improved accuracy. By giving exactly the right data, you improve the completeness and the accuracy of the response that you get. You also get faithfulness. Terms differ for this across the industry, but essentially it means limiting hallucinations. By giving an LLM your context data and saying, use this data and only this data to answer the question, studies have shown that this improves the accuracy of your data and limits the number of hallucinations that you get from LLMs. You also get recency. You can, to some degree, improve accuracy and faithfulness by fine-tuning a foundational model on your data, but that is a time-consuming and expensive way to do it. And your data changes all the time. Sometimes your data changes in real time. Using retrieval to provide your data in real time, the most up-to-date data to your LLM, is how you manage to stay up to date when you're running a RAG application. And finally, there's provenance, by which I mean the LLM can say where it got the data. Being able to cite your sources is good in academia, but when you're talking about a search application, sometimes that is the point of the application, is you want to know what document did this data come from. And that's something that RAG can help you do. So those are, very quickly, why we do RAG. Let's talk about how we do RAG. Like I said, the core of RAG is retrieval. You have to select some subset of your data so that you can give it to the LLM. And there are a bunch of ways that you can do that. One of the most obvious ways is to use just keyword search. It turns out that we've been building keyword search algorithms for 30 or 40 years now, where they're pretty good at this point. If you know that what you are doing, the data that you want can be located with a keyword search, there's no reason not to use a keyword search algorithm to retrieve your data and use that to provide context to your LLM. There are also structured queries. If you have a huge relational database, there is no reason that you should take all of that relational data and just dump it into a pile of text and give that to an LLM. A relational database has all of this really useful context about how data relates to each other. So what you can do instead is you can get the LLM to write SQL queries for you. They're getting pretty good at doing that. And you can get the LLM to retrieve data from your structured database. And finally, there's vector search, which is the one that you hear about most often, partly because it's the new kid on the block, but also because it's really uniquely powerful. For vector search, the first thing that you do is you convert your data into numbers, specifically gigantic arrays of numbers called vectors. The models that do this work are closely related to LLMs, and what they do is they encode your data as meanings rather than as keywords. The total set of available vectors is enormous, and it is known as vector space. So converting your text into numbers is therefore known as embedding your text into vector space. And the resulting numbers are known as just embeddings for short, which I think is a particularly misleading name because it's so many degrees of indirection away from what you've done. But the effect of embedding all of your data this way is that you can then take your query and embed your query into vector space in the same way. Because of the way vectors encode meaning, the answer to your query is going to end up mathematically nearby in vector space to the data that will answer the question. So you can use relatively simple math to locate vectors that are nearby to your query vector, and that will be the context that you use to feed to your LLM and answer your question. So that is the core of how RAG works. You embed all of your data, then you embed your query, you retrieve context that's nearby to your query, and you feed that context and your query to an LLM. And the LLM gives you an answer to the query. It's not just regurgitating the context you retrieved, it's contextualizing and explaining and summarizing it as well. So you can use this amazing vector search, or you can use keyword search, or you can use structured queries, but of course you can do better by using all three at the same time. Keyword search is going to work really well if you happen to search for the right keyword. Vector search will work if you are searching for the correct concept. But in practice, you'll want to mix all of them, and we'll talk about how to do that later on. So that very quick summary of how RAG works brings us to Llama-Index. Llama-Index is an open source framework that connects your data to LLMs. We are available in Python and TypeScript. And we also have some commercial offerings. In particular, we have a thing called Llama-Parse, which is the very best PDF parser in the world. Llama-Parse will parse even the most complex documents into something that an LLM can understand. It has, in particular, a feature called parsing instructions, where you can explain in natural language terms, what is this document that you are looking at and how should you parse it? That can really dramatically transform your document from something very complex into something much more simple that an LLM can understand. Llama-Parse is free to sign up at cloud.llama-index.ai. So you can use it in your hacks because it has a limit of something like 1,000 pages a day, something you're not going to hit in the course of a hackathon. But that's getting ahead of ourselves a little bit. Let's talk about the structure of a RAG application. This is a typical RAG pipeline. First, you load your data from your sources, wherever they happen to be, and you ingest and prepare it to be processed. Then you index your data, which means embedding it and preparing it for vector search. Then you store your data, which means putting it into a vector store of some kind. And there's all sorts of choices to be made there about how you do that. And then when you're ready to query that data, you first have to retrieve the most relevant context. Once you've retrieved your context, you combine that context with a prompt, like I was saying just now. And finally, you get your result. Depending what you're doing, that might require further processing, like turning it into valid JSON or something like that. There's a lot going on here. RAG is a magical technology, but magic is tricky to get right. So let's talk about how Llama-Index gets involved at every stage of this process. Before you start, you have to pick your LLM. We support dozens of LLM models and more every day via APIs like Ollama and hosted options like BentoML. So if you're interested in brand new models like Phi 3 and Llama 3, you can use Ollama with Llama-Index to get access to them on your local laptop. Let's start with ingestion. The very simplest form of ingestion is just to load a bunch of files that you have on your disk into memory directly, which is what is happening here. In Llama-Index, you can do the first part, loading the data in one line of code. You're loading your data from a directory called data and you're converting it into documents. The simple directory reader here can handle a huge variety of file formats, including CSVs, PDFs, and Word files, and also things like images, audio, and video for when you want to do multimodal things. What if your data isn't in static files? What if it's in Google Drive or Notion or a database of some kind? Here we provide a registry of software called Llama Hub, available at llamahub.ai. The Hub provides a huge library of software that lets you perform all sorts of tasks, including data connectors to connect to every data source that you can think of, obviously including MongoDB. There are also tools for building agents and a bunch of other things in there that I'll talk about as they become relevant. So if you need to load from some other source, you can check out those connectors on Llama Hub, but for this example, we're going to stick to Simple Directory Reader. If you are happy with the defaults of Simple Directory Reader, then you are done, and you can go to the second line, which is where you index that data by sending it to an embedding model. By default, Llama-Index is going to send your data to be embedded to the OpenAI embedding model. But all of that stuff can be customized, as we saw in the previous talk. You might not be satisfied with the defaults of how we ingest documents. So in that case, you will want to build an ingestion pipeline, which can look something like this. This lets you configure a series of transformations about how you want to split up your documents for embedding. You can specify what metadata you want and what embedding model to use and stuff like that. But the result either way is that you get a set of nodes, which you can then start indexing. In production, you'll probably end up running, in development, you'll probably end up running the same pipeline repeatedly. And so for that reason, we provide ingestion caching, which allows you to repeatedly run your code without having to re-ingest all of those documents every single time. It will only change the parts that have, it will only rerun the parts that have changed. That brings us to indexing. As I mentioned, this is a stage where you take your chunks of data that you've just created and you embed them into vector space. We support a huge set of embedding models, like we support a huge set of everything. The default is OpenAI, but you can use all sorts of models, including local models, by using things like Hugging Face to download local embedding models. The workhorse in all of this is the vector store index class, which takes care of doing all of that embedding for you, whether it's coming from a remote API or from a local embedding model. You will see us call out to vector store index over and over in these examples. Depending on your use case, you may also want to check out our knowledge graph index. This can take unstructured text and split it into entities and relationships and perform entity-based queries on that data. But I would include the strong caveat that people tend to reach for this before they need it. LLMs are very good at figuring out relationships between entities within piles of plain text, so you don't necessarily need to create a knowledge graph to be able to run complex queries. So now you have all of your embeddings, and it's time to store them. We support dozens of vector stores, including MongoDB, obviously. Vector stores take these giant piles of numbers that you've created and allow you to search against them using vector math. However, there's differentiation in the space in terms of other things that you can do, and we'll see those in the next couple of slides. So now we are at the querying stage, the thing we're not going to be talking about too much today is prompting. Other RAG frameworks talk a lot about prompts and prompt engineering, but at Llama-Index, we take a different view, which is that we are a batteries included framework, and that means that we have come up with excellent prompts that we know work. They are tried and tested and finely tuned, and we've built them into the framework so you don't have to figure out prompting all by yourself. Of course, if you want to, you can modify the prompts. That starts with the most basic thing, which is inspect the prompts so that you can see what they are. That's how you do that. And then, of course, you can customize them. The syntax of prompt customization will be very familiar if you've used any other library to do this stuff before. So like I said, we are now ready to query. Let's start with the most basic form of querying, which is we take the index that we created previously and we tell it to give us a query engine, and then we run a query on that query engine and print the response. This is the end of a RAG pipeline. You have done everything. You have ingested, you have indexed, you have retrieved, you have queried, and you've done it all in 5 lines of code, which is the great thing about Llama-Index, is that you can do all of this stuff very, very simply, and you can focus on customizing the bits that you want to customize. Of course, like everything in Llama-Index, it can be customized if you want to. One thing in particular that you might want to customize is how many pieces of context we retrieve. By default, we retrieve the 2 most relevant pieces of your data. If your chunks are very big, then that might be perfect. Those 2 chunks would have a large and relevant set of data for you. But if your chunks are much smaller, for instance, if you're indexing something like tweets, then you're going to want way more than 2 to be able to provide enough context to answer your question. So here's how you create a vector index retriever. This is a custom retriever, and you can set similarity top k, which is the number of chunks that you retrieve when you retrieve. The next stage is you have to configure a synthesizer. A synthesizer is how the engine puts your query together with your context and sends it to the LLM. There are a bunch of available response modes here that we don't have time to go into, but effectively what they all do is group your chunks of context together and query the LLM. And finally, in this customized version, you create your query engine by combining your retriever and your synthesizer, and then you query your LLM just like we did before. So that is the basics of running a RAG application using Llama-Index. You've run through how to load the data, how to index the data, how to embed it, how to query it and how to customize your retrieval. So now let's look at the advanced strategies that I was talking about. The first of those is called the sub-question query engine. What the sub-question query engine does is it addresses the problem of a very complicated query that would require multiple different data sources to answer the question. What it does is it breaks your query up into multiple smaller, simpler queries, runs each of those simpler queries against a different query engine that can answer that particular sub-question, and then it combines and summarizes the answers into a single answer, which it returns to you. The way that you do this is you create an array of query engines, and you provide them as query engine tools. In this example, we're just creating an array of 1, but obviously you could create as many as you wanted. And what you do here is you provide a query engine, just like the query engines that we created earlier, plus some metadata. The metadata is how the LLM decides which query engine it should use to answer which portion of the question. Once you've set up your tools, down at the bottom, you can see that you set up a sub-question query engine, which is a built-in in Llama-Index, and you give it the set of tools. The next problem that you might want to tackle is precision. And a basic RAG pipeline can struggle with making sure that the context is precisely related to the query. And one tactic for handling that is what we call small to big retrieval. In small to big retrieval, what you do is you customize your chunk size, like we saw earlier with the ingestion pipeline, and you break your document up into very small chunks on the order of a sentence long. And you run your retrieval on those sentences. Because your chunks are so small, you know that those chunks are going to be really very precisely related to your query. However, that's probably not going to be enough context to answer the question. So then what we do is we look backwards and forwards within the document that the chunk came from, and we retrieve 5 sentences worth of context before and after the sentence that we specifically retrieved. And we give all of that context to the LLM. So you get precision with context at the same time. Getting this done in Llama-Index is disarmingly simple because we've done all of the work for you. When creating our query engine, we can supply a list of node post-processors, which work after retrieval, but before the synthesis stage. And we use the catchily named metadata replacement node post-processor with a target metadata key of window to automatically search through nodes. And it will link together the previous and next 5 nodes before sending the query to the LLM. Small to big precision is small to big retrieval is precision by post-processing nodes, but you can also get better precision by pre-processing your nodes. One way that you can help the LLM out is to use existing metadata that you have about your data and filter on that before retrieval. A very popular example of that is on financial documents. Financial documents are about a specific year. You know what year they're about before you index them. So there's no reason that you should force the LLM to have to try and figure that out. You can tell the LLM, this document is from 2021. This document is from 2020. The way that you do that is you embed metadata into your documents when you are parsing your documents, and then at the retrieval stage, you can supply filters. In this case, you can see we're using an exact match filter, which is looking for a key called year and a value called 2021. The metadata that you can provide to your documents is arbitrary. So you could provide, a key or a color, a key of a year or like color or type or, name, user, whatever you want, and provide any values for those and then filter on those. By default, you're going to have to specify what this filtering is in advance, but you don't have to do that. One of the even cooler things that you can do is you can get the LLM itself to decide how to filter your data before it runs a query. The way that you do that is you create this vector index auto retriever in which you supply metadata about the keys that you have provided in your metadata. So you say, for instance, that the year is the year the movie was released and the director is the name of the movie director. And then the LLM is able to figure out, okay, this question is about this particular director. I know that I have a key that will allow me to filter down to this director. I will run that filtering in advance. And the LLM can do that on its own behalf without you having to do it. As you can see from this list, most of the vector databases we support also support metadata filtering. So that is good news for you. My next example is hybrid search. I mentioned this earlier. You can combine traditional keyword search with vector search and then do combined retrieval of both of those. Once you've got a database that supports hybrid search, using it is extremely easy. All you do is you pass a parameter to your query engine called vector store query mode hybrid and a parameter called alpha. Alpha determines the degree to which the search relies on results from keyword search or from vector search. 0 means that it relies entirely on keyword search. 1 means that it relies entirely on vector search. And obviously anything in between those two is some blend of them, and you can tune that based on the results that you're getting. As you can see, the list of vector databases that also support hybrid search is a lot shorter, but everybody is rapidly adding this feature. Another use case for advanced retrieval is complex documents. Not every document is just a pile of text. They often contain complex tables, diagrams, and things like that. So let's consider how we can break down a complex document into a set of simpler elements. To do that, I need to introduce you to our ability to query tables. We have a fantastic built-in Llama-Index called the Pandas query engine, which allows you to create a Pandas table in Python, and using the LLM, it can generate correct Pandas calls to query those tables to get the right values. What you can then do is provide a description of each table that either you've created the description manually or you've got the LLM to derive the description, and it will create a series of what are called index nodes. These look like the regular nodes that we got from parsing our documents earlier, but the retriever will know that when it encounters an index node, it should treat it specially. It should treat it as a data structure, as a table. So then you need to create a dictionary that consists of instances of the table structures that we were talking about. Now, for completeness, I'll just show how you would parse the rest of the document there. You would create a vector store index using both regular document nodes and the special table nodes that we were talking about creating. And you'd pass them both to your vector retriever. And finally, we set up a query engine just like we did earlier. The recursive retriever is the retriever that understands what to do when it sees one of these special index nodes. And you create a response synthesizer and pass both of the retriever and the synthesizer to the retriever query engine, which is now able to do these complex queries that can involve querying tables instead of just basic text. As I mentioned earlier, a very common advanced retrieval use case is wanting to query a SQL database directly. So let's talk about how we do that. Under the hood, Llama-Index is using SQL Alchemy, which if you've ever done data work in Python, you'll already be familiar with. Here we are just connecting to a database and initializing Llama-Index's own SQL database class. The SQL database class is handled by the natural language SQL table query engine, another one of those very long names that we specialize in. What this does under the hood is it takes the schema of the table that you're passing in and passes it to the LLM so that the LLM knows what rows and columns exist in this table that it can query. And then it gets the LLM to generate SQL that will query that table. This is obviously complicated stuff. Generating good SQL is something only the best models do reliably at the moment. So GPT-4 or Claude Opus both do a pretty good job at it. This works well if you know the name of your table in advance and you know and you're sure that the schema will fit into your prompt. But sometimes that's not true. Sometimes you're going to have hundreds of tables that you want to be able to query. And you're going to need to get the LLM to be able to select before it starts querying which schemas it should be looking at. The way that you do that is by creating a SQL table node mapping, as we're doing here. You can pass as many tables as you want to the table node mapping, and create an index for each of these tables to be turned into a retriever. Then what you do is you pass metadata about each of these tables and say what they're for. This allows the LLM to decide based on the metadata which table is most likely to be able to answer the question. And then it can look up that table in the index, get the schema, pass the schema and your query to the LLM and get it to write SQL just like before. The final use case I'm going to talk about today is the one that we've been talking about mostly, which is agents. Our favorite example of agents in the wild is a demo application that we call SEC-Insights.ai. SEC Insights is an application where you give it financial filings documents from one or more companies, and it can compare, contrast, and summarize them. The best thing about this demonstration, this demo app, from your perspective, is that it is completely open source. So if what you want is something that can compare and contrast documents, which is a very useful use case, you can go to SEC-Insights.ai and fork this application, and you will get 80% of the way there towards the application type that you want. And it's obviously open source, so you can do whatever you want with it. What it's doing under the hood is creating a set of query engines. In this case, I've created 3 identical query engines, each of which queries documents from a different year. However, you could be using any of the different strategies that we're talking about today. So one of them could be a regular query engine, just querying a pile of documents in a folder. One of them could be a text-to-SQL database. One of them could be a pandas query engine. One of them could be a sub-question query engine. All of these strategies that we're talking about can be composed with each other. And now, because we're creating an agent, we have to create tools. In this case, we are creating a query engine tool and passing in a query engine, again, with metadata.
Laurie, hey, I apologize to interrupt you. Just a small note that we need to wrap up soon, so we're good, right, with the presentation?
Yep, I'm on my way to finishing.
Awesome, thank you. Sorry, thanks.
So, because it's, like I said, when you create an agent by creating a set of tools, and you give the tools metadata to say what the tool does, that is how the agent decides which tool to use. Now we define our agent, which is surprisingly simple. In this case, it's an OpenAI agent. We give it the set of tools that we created, and we give it a system prompt that says, what is the overall goal of this agent? In the contrived example I was just giving you, our query is very simple and the tools are very simple, but like I said, you can compose all of these strategies. So you can have agents that call other agents, and agents don't just have to perform queries, they can also take action. Since I'm running out of time, I'm not going to be able to show you the demonstrations of agents in action, but I will link to resources that let you see them. Let's talk very quickly about getting this stuff into production. One of the best ways to get your AI creation into production is to get a fully working web app built for you by a tool that we call Create Llama. This will generate an application for you, a front end in JavaScript and a back end in your choice of JavaScript or Python. And again, it's a way to get 80% of the way there. If what you're building is a chatbot that queries data and provides a chat interface, Create Llama is an excellent way to get started. I'm going to skip these slides and take you to the resources section. The best thing to go to is docs.llama-index.ai. That is our Python documentation, or ts.llama-index.ai, which is our TypeScript documentation. Also, you'll see a bit.ly link there, which will take you to this document, which I think you can see, which is a huge set of resources sorted by beginners, intermediate, and advanced, of all sorts of things that you can build, including agents. And since I'm running out of time, I think I will stop there.
Thanks, Laurie. Thank you very much. Sorry for this, I'll just say notice. Yeah, it's just like we were a little bit out of time before, but thank you very much for your presentation and for workshop about rack system. So I would be happy to invite the next speaker from
All right, is this stable now? Yeah, tell me when I'm live. Mm, I have started the sharing. Yeah, I gave it all the permissions.
Yeah, sure. Just give me 1 second. We'll go with camera. Yep. Can you hear me guys now? Yeah, and see me? Cool. Yeah. Okay, so we are experiencing some technical issues here with the presentation done by Prakul. and we will have to take a small break for about 5 minutes, I hope. So maybe even less, I think, even, yeah, 2 minutes, guys. Just please very quickly, and please stay here on the channel. Okay. Hey again. So we are back with the stream. Now we have Prakul. Prakul is the product manager, machine learning manager at MongoDB. He's going to give today workshop on the RAG enable for LLM success creation. So I am passing mic to Prakul for his workshop. It's going to be a half-an-hour workshop, so please stay tuned and have fun.
Hi, everyone. I'm Prakul. Good to meet you all. So, as most of you would be aware of MongoDB, so I want to talk about MongoDB Atlas Vector Search. So this is a native vector database capability that's integrated in the MongoDB Atlas platform. So we started doing this in private preview right before ChatGPT blew up in popularity, came on the scene, sort of the recent databases became super popular. And we have had customers been building on this, shipping on this for a while. So what vector search allows you to do is essentially build use cases like semantic text search, image search, retrieval augmented generation, recommendation, etc. So the topic of this discussion, right? Like, it's kind of like, we talk about generative AI applications, we talk about LLM applications. So MongoDB essentially is the long-term memory that allows for a lot of the reasoning. So just at a very high level, right? What does a semantic text search mean? So you're looking at using a query from a user, being able to retrieve it from your database based on the meaning of it rather than the keywords that are contained within that query. So example of this would be doing a meaning-based search on images right? In this case, searching for houses with swimming pools, you don't really have descriptions for those images, but you're using a model that can understand images and allow you to do that. Similarly, like Q&A powered by this example. So if a user had a query that you would ask an LLM, how much better is, let's say, GPT-4 in reducing hallucinations? Without RAG, it would hit into the limitation of the knowledge not being part of the parametric memory with which it was trained. So you get a response that's on the left, where it's basically saying it's not something I know. Using RAG, we are able to get to a right answer, as this answer knowledge was contained in a knowledge document in a PDF that we were able to feed to a vector search, and it was able to get the right context to an LLM. So just quickly, maybe I'll just talk about like how we think of this. So you're very much aware of the document model that MongoDB has, which is essentially that looks like on the screen. So a kind of a JSON object you would have all your data in. So let's say you have a catalog for stock transcriptions that have happened. So you would store your embedding, which would come from a large language model, a generative embedding model that would store right there in your data. So on whatever particular field that you want to search for, just be able to enable a vector search index on it. And in this case, we are telling that it's a type vector, and we are interested in the path content embedding, and we provided the number of dimensions of what that array of float is. In this case, it is something that's using OpenAI's embedding model. So it comes with a size of 1536. That's what you specify. And you provide a similarity score. That could be a Euclidean, dot product, cosine, etc. So your data is ready, prepared for being able to do vector search on it. So in this case, there is an aggregation stage of $vector search where you provide the embedding for your query vector against a certain path that you're trying to search, and you provide the k parameter, essentially the number of neighbors closest to that query that you're trying to retrieve. And then there is a parameter for tuning called num candidates that allows you to improve your recall with some hit in your performance. But what it does is essentially a kind of number of HNSW entry points to explore. So HNSW is the algorithm, the methodology that's used for powering this kind of an approximate neighbor search. And it stands for hierarchical navigable small world graph. So like just with this simple construct, like you can start performing semantic search on your data, right? So just a few examples. Things would look really the same, right? If you're doing a text search, something like give me houses in New Jersey, sure. Similarly with just the previous query that we talked about, houses with swimming pool. In this case, we use a model from OpenAI called Clip model, and we go off that instead of a text-based model which we used previously. And you can also use this for doing a image to image search. Like in this case, input instead of being an image, instead of being a text, is an image that you provide, and you get similar images to that. So all of these are really parts and parts, or like an approximate KNN kind of a search. We're trying to find objects that are similar in nature. So this was the overlay of like what semantic search and retrieval in general looks like. So now it comes to the point of what exactly is RAG, right? So Laurie already covered well in his presentation, but at a very high level, we are looking at a normal generative AI query where you're querying LLM directly, getting a response. So LLMs could be from multiple sources, open source, closed source, bunch of options. With your RAG, we essentially intercept that query, pass it to a vector database, get the additional context that we pass on to LLM. So in practice, how do we think of that? So it's essentially a two-stage process. The first stage being on the top right, which is all your private knowledge sources, could be structured, unstructured. So unstructured sources are like your PDF, your Google Docs. More structured examples are MQL, SQL kind of docs, more tabular data. Also audio files and image files that you would put into an indexing pipeline and store it into your database. Secondly, when the user query comes in, user asks a question, you put it into a pre-retrieval process, process the query, put it into a vector search, get that context into a post-retrieval process, pass it into an LLM, and you get an output that's specific, well-informed answer, rather than something that is coming out of completely the LLM and you have no control, right? Like, so with this kind of a process, with this RAG, you can do things like attribution of the sources on what actually basis of the answer is. You can do things like automatic role-based access control for who gets to access what data. Example of that being a workplace chat where you're trying to search for salary of employees. Now, if you're the CEO, you can look at all the employee salary, but if you're a employee, you should not be able to look for random people's salary, right? So that's where like some of the role-based access control that LLM may not know, but you have your knowledge overlay on who gets to access what, that you're able to present to these retrieval systems. But what does this ingestion looks like, right? In a more detailed manner. So very high level, we take any document, we chunk it. Chunking is a process of breaking it down. We store those chunks into a data store. We create embeddings by passing it on to one of the many embedding models, and we store it into the vector database. Similarly, on the querying side, we take the query, embed it, put it into a vector search, get the results. In this case, for the query, how much better is GPT-4 that we talked about earlier, we got all these chunks with the text and the similarity score. So each of these chunks are retrieved from that original document that we supplied to it. And with this is the cosine similarity score. So we know how confident we are of this being closer to the query that the user is asking for, how much of that semantic overlap there is. Pass it on to a prompt. So prompt is instruction specific to the LLM. So this would have instructions on what role LLM should be like and what all guardrails it should provide and how it should process this provided context. And with that, you get to your answer that we are looking for. So now this process of search systems that we talked about in the beginning, some of the examples, and an extension of that, which is your retrieval augmented generation, where after you're retrieved, you are generating something with it. If you were building an agentic application after you have done your retrieval, you would want your agent to be able to execute, reason on that context, and perform an action. Like as a tool, go in, make something happen, make a change happen in Slack, for instance. But within this process, right, it's very important to understand it's an iterative process. Like building better retrieval system is something that needs to be checked and evaluated, right? Like right now, as you get started, a lot of the checks are just about vibe based. Does it look good? Sure, but like as you get in deeper, having some benchmarking, some evaluation mechanism, like what Truera offers, can be super helpful. But that's where a lot of gains come from, like often off-the-shelf system. This is the kind of process where you can build much better question answer systems. So specifically, we want to focus on what all things that you can do at the indexing level when you are taking in your data and putting into vector database. So to be able to do this, right, like there are these two approaches. So one of that is kind of one on the top right, which is using a bolt-on separate dedicated vector database, which you use in conjunction with an operational store, which contains all this data about your knowledge base and stuff. And then you are using two different query languages to put together your operational database and your kind of vector database, as well as taking care of ETLing and migrating, putting data as things change in your source. Suppose a chunk changes, user information, you have to put that ETL it into a vector database. So adds a bunch of complexity and I would show examples on where that can be problematic from just the data modeling aspect of things on what you can express, because whatever you are expressing is what you're able to retrieve. And on the bottom right is how MongoDB thinks about this with the integrated vector capabilities. So important thing to keep in mind, building good retrieval systems is about being able to search vector embeddings, but also the metadata, structured data, and all text data, which is like your sparse text-based search. Different use cases, different scenarios where you can meaningfully and very visibly improve your accuracy by being able to combine all these data sources. So just for an example, like to revisit MongoDB's document, how you would store this, how you would iterate on this. So we have an example of a movie catalog. Fields you would think of a movie, a poster, link to a image file, plot, the country, the year it came out, genre, etc. So at a very naive basic level, the data modeling for doing this is we can do text search on it. That comes integrated with MongoDB Atlas. We do a vector search by adding on a vector embedding field. But now in this kind of a data modeling, there are some low-hanging fruits in terms of being able to improve the retrieval performance. So one such benefit of having this flexibility of document model is that you can make changes to the fields. You can add things in the similar zone without having to make multiple copies of things. So an example of that is being able to have multiple vector embeddings in the same document. So in the same movie catalog that we talked about, which is referring to one of the objects, one of the movies, we are showing an example where you can have embeddings from different models, right? Like so OpenAI, some open source models on Hugging Face, some other ones on other inference providers, but also we can see one of them embedding is on plot field, which is one of the fields that's like a smaller version of the full plot, right? So plot is this, there is a full plot, and there's also embedding which is corresponding to full plot. So now you can actually be able to, like, using these different scenarios, get different results. And it's a matter of testing and iterating on how this makes a difference to your scenario, right? So for example, retrieval systems typically, with larger chunks of text, it actually may not work that well because there are too many semantically similar concepts that are there. So it's better to split it, and having sometimes smaller context helps. That's maybe plot will help you understand. Example of that is things being able to understand the genre of the movie, right, or the sentiment of the movie. With the larger plot, you can get more complexity of those emotions to be able to put together something that's more meaningful than just looking at the plot of the movie, which is a smaller summary. And the second piece is about trying out different embedding models. So different embedding models come with different retrieval accuracies, right? So there is an MTB leaderboard that a lot of you are aware of, which showcases how different models perform in different scenarios. So that's one piece, like what works on your data set in your use case. You will see meaningful differences in different embedding models. So being able to model it this way allows you to test and verify what's working well. The second piece to this is the cost. So OpenAI, for instance, has a bunch of embedding models now, the largest being 3,000 plus dimensions, smallest being 256 dimensions. So there is difference in cost for those. Firstly, just from how much you're paying the embedding model to generate those embeddings, but also how much you are paying to store it in the database. Then there's a question of if you were doing a lot of retrieval queries. Let's say you put your app in production, it's super successful, you're getting millions of views, reads each day. You would start getting into massive bills with just running these embeddings, which is not something you consider in your development. So that way, just trying out these different combinations and being able to understand how your retrieval performance is changing could be super meaningful to improve accuracy and drive down cost. The second piece, which this MongoDB's document model allows for is something called parent document retriever, right? So with a lot of the other implementations, you would have to use two different databases to put this kind of a thing together. But what like a parent document retrieval does is you have a document chunked into certain size, and then you break down each chunk into smaller chunks. The reason you would do this is because, as I said, retriever, the vector search part works better on a smaller chunk size. But if you provided a small chunk to the LLM, it won't perform that well. So that's where you want to do a parent document retriever, like, just from a small chunk that you use for your retrieval, get me the larger document of which it is part of, and feed that larger document to the LLM. Because this larger document will come with more lines around that line of code, or the line that you're trying to search for, which will provide LLM better context. So this is something that comes in with that data modeling that you can achieve with having that flexibility of the document model and having your metadata embeddings alongside your other data. So now that brings us to how do we improve the accuracy of what is being retrieved, right? So what we covered previously, some examples of thinking of how you insert and index your data. Now we are really thinking about, now that data is in there, what can I do on the query side to improve the performance? So in the rack stack, we're looking at retrieval now. Now with that comes the capability or ability to be able to do this rich filtering, right? What that means is, now that you have your data stored in a manner that you are able to reason well with, but you also need equally good capabilities to extract meaning out of it. So naive vector query, start with that, then add on to that some aggregations. Example query for that is, find me the images that are similar to the query image. That's great with vector search, but now you want to group them by photographer ID. So with MongoDB, you can do this in a single pipeline. You can combine this with metadata for filtering. Find me content matching users query, but only something that's published in the last 3 months. Or combining with a geospatial search, right? Which LLMs are not necessarily good at, but your databases are. And recommend me restaurants that match my taste, but only within 10 miles of my current location. Such a retrieval query, you need to understand what the user's location is. You need to have a tagging of restaurants on where they stand, and then be able to understand users' preference, their taste. And this is a good example of like combining all these different knowledge sources. So you need a equally rich querying capability. So retrieval with MongoDB comes down to starting with vector search, adding on metadata pre-filtering to that, layering on that some post-filtering, also being able to combine this with full text search, right? As was mentioned previously, this is a keyword-based search, which has been perfected over decades. BM25 is one very leading example of the sparse model, it's sparse embeddings kind of a thing, and then being able to combine these vector search, text search with something to put together like a hybrid search. The reason you would want to combine user text search is, especially in like out of domain kind of languages, like, let's say you had your own movie collection that is not part of public internet. That's not like normal, like you are the movie producer, you make your own. So now all those terminologies, all the characters, etc., the sentiments is something your embedding models will not be great at, right? Because they have not learned those things, especially if you're using some other made up language, let's say. So that's where filter, like a text-based search, works really well there, because that's what it does, like keyword matching. So your query will have those keywords, but now you're able to combine that with semantic-based meaning wherever that works, and be able to control how much emphasis to pay on what, right? So that's how you put together a really powerful retrieval system, and you can see the benefits of being able to track these. So just to give a motivating example, like, we start off with a basic query. Let's say, give me all the comedy movies with imaginary characters released between 1980 and 1990. do a vector query, you will get some results. But what you will quickly realize, it's not very good with reasoning about date. Not all movies actually fall in the range of 1980s and 1990s because it can confuse, it doesn't understand it's talking about the release date, it can think the concept 1980, the number 1980, all those things may not be available in just the plot embedding, right? So what you would want to do is break down that query into two stages. Just do so you for decomposing this query, you can just do something like comedy movies with imaginary characters. That's something that your vector databases are really good at, your semantic search is really good at. And the second part being movies between 1980 and 1990. That's what your keyword based search or your filtering is really good at, right? So for MongoDB, you have support for dates as a native filtering type. At the first stage, we filter it, get the subgraph of all the movies which fall in that range. And then from that, we do a semantic query, which is more complex natural language query to get our final results. This would be very different if you were doing this in an opposite way, which is post filtering, the vector query being the first part, and then the filter being the second part, right? So in this case, you will actually getting wrong results because with vector query, the comedy movies that landed up there, one of the movies was from year 2000. This had really high similarity for the user query. That's why it popped up in your top results. And the one from 1980, which would have been the right answer, that did not show up in this list that you wanted to put together. So that's how all these different operations can have an impact on your retrieval accuracy and by implication your RAG system. And this is another example of that hybrid search that we talked about, where for the same query, you want to do a text search and a vector search, combine them together. There are different methodologies for doing that. And that way you can get a really good fused result set. So just wanted to go a little bit deeper into this concept of pre-filtering that is really powerful, right? So whenever you're talking about a model document that you already have, we can add filter to it by simply adding this piece to the index definition. And the power of having an integrated platform is that now you don't have to do anything. The system will take care of it. MongoDB is a managed service. It will get you to that without you having to do any data synchronization. And very easily, you are able to incorporate this new filter type into your query without any changes in your syntax. Now, one thing that you would notice here is that this filter that we are doing is a little complex filter, right? It is talking about symbol being in a certain array. And this can be pretty powerful, right? This is what having more complexity in your query syntax can bring in over just a pure vanilla vector search. So with MongoDB, we have a bunch of these MQL pre-filtering syntax: greater than, less than, greater than equal, less than equal, not equal, in an array, not in an array, and or. So you can compose all the above together. So these all are part of Llama-Index that we expose, all the different filtering capabilities that you can do there if you're using Llama-Index. And you can also do this directly in MQL. So just an example of what that powerful composable queries can do for your retrieval accuracy, right? By being able to add on these stages. In this case, we are using an AND operator and saying, give me only results which are within certain array, but not in certain other arrays. So stuff like that. And you can also have multiple stages where you can, this is an example of how you would do a post filtering kind of a thing, right? So you do a vector search and you do a secondary stage, which works as the pipeline. Second. And you can do a bunch of things, maybe turn on, turn off the search score, use that search score for re-ranking in your subsequent stages. Bunch of possibilities that it opens up. So with that, this was a lot of information. Hopefully puts the right mental picture in your head on how you would continue to improve and fine-tune your retrieval system to get to a really well-performing one. So we have a cookbook with Truera that really goes into the constructs on how would you put quantitative numbers onto these different stages and steps. How would you be able to verify that? And we also have a cookbook. We have a bunch of work that we do with them. So, like using the stack, good luck with hacking. And yeah, we'll be there answering any questions that you may have.
Thank you very much, Prakul, for this workshop. So let me just quickly glance into Twitch to see if we have any questions. Just give me one sec. Okay, that's a little bit difficult to check them real time. So what we're gonna do, we're going to move forward to the Discord Q&A. We will have it anyway after this workshop. So thank you very much for everyone watching us today, for staying with us till the end, for listening to 3 exciting workshops about the Truera, MongoDB, and Llama-Index. Now it's a fair time to start Discord Q&A. Please join the channel, and all the questions that has been posted on Twitch can be also addressed during. With that being said, I will close this streaming for now. Bye for now. You will also have a chance to ask questions during the Q&A sessions on the week. Which are going to be on Monday and Tuesday. So please have fun building, creating, utilizing new technology, and you will have also a very cool tutorial prepared for TrueLens, MongoDB, and Llama-Index collaboration. Yeah, like using them together. Thanks everyone, and see you around.